Hello viewers, in today's session we are going to discuss one important problem from three-dimensional geometry related to shortest distance between two non-coplanar lines. So here we are going to find out the shortest distance between the lines L1 and L2 whose equations are given in symmetric form, and we have to find the equation of the line of shortest distance, right? So here we are not going to use the standard formula for finding out the shortest distance between two lines L1 and L2, but will use simply the distance formula to find out the shortest distance between these two non-coplanar lines, right? So in three-dimensional geometry, if we have 2 points, say A and B, and if the coordinates of the point A are x1, y1, z1, and the coordinates of the point B are x2, y2, z2, then according to the distance formula, the distance between the points A and B is given by this result, that is square root of x2 minus x1 square plus y2 minus y1 square plus z2 minus z1 square. So here I will make use of this distance formula to find out the shortest distance between these two non-coplanar lines L1 and L2. So now, according to the definition of non-coplanar lines, two lines are said to be non-coplanar if they lie on different planes, right? Suppose we have the line, say L2, and here we have the line L1. And if these two lines lie on different planes, then these two lines are said to be non-coplanar lines or skew lines, right? And the shortest distance between these two lines L1 and L2 is given by the line segment which is perpendicular to both L1 and L2. And remember, this shortest distance is unique, right? Because there is only one line segment, or there is only one shortest distance between these two non-coplanar lines, which is perpendicular to both the lines L1 and L2 at the same time or simultaneously, right? Suppose this point is P and this point is Q, and remember L1 and L2 lies on different planes. So here PQ is the line of shortest distance which is perpendicular to both the lines L1 and L2, and to find out the length of PQ, we need to find out the coordinates of the point P which lies on line L1, and the coordinates of the point Q which lies on this line L2. So let us assume that this point P is x1 y1 z1, and this point is x2 y2 z2. And once we know the coordinates of the point P and Q, we can easily find out this length PQ by using the distance formula, right? And moreover, by knowing the coordinates of point P and Q, we can easily find out the equation of this line of shortest distance in symmetric form. So now let us first apply the concept of a general point lying on a line, right? So for this, let us introduce here the scalars lambda and mu, where lambda and mu are some real numbers, and we'll find out the values of lambda and mu. So taking this line L1, we have this scalar lambda, and taking this line L2, we have this scalar mu. So the purpose of introducing lambda and mu is to get the coordinates of the general point lying on a given line. So from this line L1, we have now x1 minus 1 over 1 is equal to lambda. Then we have y minus 2 over minus 3 is equal to lambda. Z minus 3 over 2 is equal to lambda. So from here, we can now write x is equal to lambda plus 1, y is minus 3 lambda plus 2, and z is 2 lambda plus 3. And similarly from line L2, we have x minus 4 over 2 is equal to mu, y minus 5 over 3 is equal to mu, and z minus 6 over 1 is equal to mu. So from here, we can now write x is equal to 2 mu plus 4, and from here we have 3 mu plus 5, and z is equal to mu plus 6, right? So this point, that is x comma y comma z, it lies on this line L1, and this point x y z, it lies on the line L2. So here we can now take x1 y1 z1 as this point, that is lambda plus 1. Then we have minus 3 lambda plus 2 and 2 lambda plus 3. And this point q can be taken as x2 is 2 mu plus 4. Then we have 3 mu plus 5, and then we have mu plus 6. So x1 is lambda plus 1, y1 is minus 3 lambda plus 2, z1 is 2 lambda plus 3, x2 is 2 mu plus 4, y2 is 3 mu plus 5, and z2 is mu plus 6. So now the next step is to get the direction ratios of the line of shortest distance. So the direction ratios of PQ can be written like this, that is x2 minus x1 and y2 minus y1 and z2 minus z1. So these three numbers gives the direction ratios of the line of shortest distance. So from here we have now x2 is 2 mu plus 4. Then we have minus x1, so we have minus lambda minus 1. Then we have 3 mu plus 5 plus 3 lambda minus 2, and then we have mu plus 6 minus 2 lambda minus 3. So we have now 2 mu minus lambda. Here we have 4 minus 1 is 3. Here we have minus lambda, and 4 minus 1 is 3. Then we have 3 mu plus 3 lambda, and 5 minus 2 is 3, and mu minus 2 lambda, and 6 minus 3 is 3. So these three numbers are the direction ratios of the line of shortest distance, that is PQ. So now the next step is to use the condition for perpendicularity of two lines. So here we have the direction ratios of line L1 are given by 1, minus 3 and 2, and the direction ratios of the line L2 are given by 2, 3 and 1, right? So now here the line of shortest distance, that is PQ, is perpendicular to both L1 and L2. So PQ is perpendicular to L1, and PQ is also perpendicular to L2. And we know that if two lines are perpendicular and their direction ratios are say A1, B1, C1, and A2, B2, C2, then the dot product of these two direction ratios, that is A1, A2 plus B1, B2 plus C1, C2 is equal to 0, right? So here first we'll take PQ perpendicular to L1 and we'll apply this condition, and then we'll take PQ perpendicular to L2 and then we'll apply this condition. So by applying this condition twice, we can get two equations in lambda and mu. So when PQ is perpendicular to L1, the direction ratios of PQ are 2 mu minus lambda plus 3, and then we have 3 mu plus 3 lambda plus 3, and then we have mu minus 2 lambda plus 3, and the dot product of these direction ratios with this one, that is 1 minus 3 and 2 is equal to 0. So now we have using this condition, we have 2 mu minus lambda plus 3 times 1, then we have 3 mu plus 3 lambda plus 3 times minus 3, and then mu minus 2 lambda plus 3 times 2 is equal to 0. So now simplifying 2 mu minus lambda plus 3, here we have minus 9 mu minus 9 lambda minus 9, and here we have 2 mu minus 4, and here we have 6. So now 2 mu and minus 9, that is minus 7, and plus 2, that is minus 5, and here minus lambda minus 9 lambda and minus 4 lambda. So this is 9 plus 4 13 plus 1 14, and here we have 3, here we have 6, 6 plus 3 9, 9 minus 9 is 0. So we have this equation, that is 5 mu plus 14 lambda is equal to 0. So we can also write it as 5 mu is equal to minus 14 lambda. So mu is minus 14 over 5 times lambda. So now PQ is perpendicular to L2. So again applying this condition, the direction ratios of PQ are written over here, and the dot product of these direction ratios with 2, 3 and 1 should be equal to 0. So we have now 2 mu minus lambda plus 3 times 2, then we have 3 mu plus 3 lambda plus 3 times 3, and then mu minus 2 lambda plus 3 times 1 is equal to 0. So we have 4 mu minus 2 lambda plus 6, and here we have 9 mu plus 9 lambda plus 9, and here we have mu minus 2 lambda plus 3 is equal to 0. So 4 plus 9 13, 13 plus 1 is 14. So we have 14 mu, here minus 2 plus 9 7, and 7 minus 2 is 5. So we have 5 lambda, and here we have 9 plus 6 15, and 15 plus 3 is 18. So we have now the second equation in lambda and mu. So this may be taken as 1 and this may be taken as 2. So now solving 1 and 2, we can find out the values of lambda and mu. So now substituting this value of mu in equation 2, we have 14 times minus 14 lambda over 5. Then we have 5 lambda plus 18 is equal to 0. So 14 times 14 is 196 over 5 lambda plus 5 lambda, and we can take 18 to the right hand side. So we have minus 18. So now 5 times 5 is 25. So minus 196 lambda plus 25 lambda over 5 is equal to minus 18, and minus 196 plus 25 is minus 171 lambda over 5 and minus 18. So minus and minus get cancelled. So we have 171 lambda is equal to 5 times 18 is 90, and we have 90 over 171, right? So now here we can simplify it or reduce it to the lowest terms. So we have here 3 times 30, and this is 3 times 5 15, and then 7, and here 3 times 10, and this is 3 times 19. So the value of lambda is 10 over 19. So let us substitute this value of lambda in equation 1. So now we can write here mu is equal to minus 14 over 5 times lambda. Lambda is 10 over 19. So this is 5 times 2. So this is minus 28. 14 times 2 is 28 and 19. So the value of mu is minus 28 over 19. So lambda is 10 over 19, and mu is given by minus 28 over 19. So now we have the values of lambda and mu, and we can easily find out the coordinates of point P, which is in terms of lambda, and the coordinates of the point Q, which is in terms of mu. So here we have now lambda is equal to 10 over 19. So taking lambda is equal to 10 over 19 in this coordinate, we have here 1, then minus 3 times 10 over 19 plus 2, and then 2 times 10 over 19 plus 3, right? And here we have 10 plus 19 over 19, and here we have minus 30 plus 38 over 19, and here we have 20 plus 57 over 19. So we have now this is 29 over 19, and this is 8 over 19, and here we have 77 over 19. So the coordinates of the point P, which lies on this line L1, are given by 29 over 19, 8 over 19, and 77 over 19. So similarly, we can substitute the value of mu in this coordinate. So we have now here 2 times minus 28 over 19 plus 4, then 3 times minus 28 over 19 plus 5, then minus 28 over 19 plus 6. So we can now write here this is minus 56 plus 19 times 4 is 76, and here we have minus 84, and then we have 19 times 5 is 95 over 19, and this is minus 19 plus 19 times 6 is 114, and here we have 19. So now we can write here 76 minus 56 is 20 over 19, and here we have 11 over 19, and here we have 114 minus 28 is 86 over 19, right? So the coordinates of the point Q are given by 20 over 19, 11 over 19 and 86 over 19. So now the distance, that is the shortest distance PQ, can easily be calculated by using the distance formula. So the coordinates of point P are known to us. Similarly, the coordinates of the point Q are also known to us. So here x1 is 29 over 19, y1 is 8 over 19, z1 is 77 over 19, and x2 is 20 over 19, y2 is 11 over 19, and z2 is 86 over 19. So now here substituting the values, we have now x2 minus x1, so we have 20 over 19 minus 29 over 19 square, and then we have 11 over 19 minus 8 over 19 square, and here we have 86 over 19 and minus 77 over 19 square. So now we have here this is here the denominators are same. So we have 20 minus 29 is minus 9, and here we have 19 square. 11 minus 8 is 3, so we have 3 over 19 square, and here 86 minus 77 is that is 6 plus 3 9, so we have 9 over 19 square. So now we can write here this is 81 over 361, and then we have 9 over 361, and here we have 81 over 361. So the square of 19 is 361. So we can now write 81 plus 9 plus 81 over 361. So now this is square root of 81 plus 9 plus 81 is 171, and here we have 361, right? So now let us reduce this fraction, that is 171 over 361, into the lowest term. So here we have 19 times 19 is 361, and 19 times here we can have 9, right? Because 19 times 9 is 9 times 9 81, and 9 times 1 is 9 plus 8 71, right? So we have 9 over 19, right? So we have square root of 9 over 19, that is 3 over square root of 19. So the square root of 9 is 3. So the shortest distance between these two non-coplanar lines is given by 3 over square root of 19. So viewers, this is how by making use of the coordinates of point P and Q, we can easily find out the shortest distance between two non-coplanar lines by using this simple formula, that is the distance formula. So now the next step is to get the equation of the line of shortest distance. So to get the equation of PQ, we have to first find out the direction ratios of PQ. And direction ratios of PQ can be given by simply the difference of the coordinates, that is x coordinate, y coordinate, and z coordinate. So here we have x2 minus x1, so we have 20 over 19 minus 29 over 19. Then we have y2 11 over 19 minus 8 over 19, and then we have 86 over 19 minus 77 over 19. So now we have 20 minus 29 is minus 9 over 19, and here we have 3 over 19, and here we have 86 minus 77, that is 9 over this is 9 over 19. So these are the direction ratios of this line of shortest distance. So now if we multiply these three quantities by 19 over 3, then the direction ratios of PQ can also be written as minus 9 over 19 times 19 over 3, then 3 over 19 times 19 over 3, and 9 over 19 times 19 over 3, because this factor 19 over 3, it appears in all the three numbers, right? Because we can reduce the direction ratios to the lowest terms, because we know that parallel lines have uh, proportional direction ratios. So here this 19 get cancelled, and here we have 3 times 3, here we have 3 and 3 get cancelled, and here we have 3. So here we have minus 3, here we have simply 1, and here we have simply 3. So the direction ratios of PQ can also be written like this, that is minus 3 comma 1 comma 3. So now the next step is to get the equation of PQ, or the line of shortest distance, in symmetric form, and we can write the equation as x minus x1 over a, y minus y1 over b, and z minus z1 over c, where x1 y1 z1 is this point, that is the point P, and A, B, C are the direction ratios of PQ. So x1, y1, z1 are 29 over 19, 8 over 19, 77 over 19. So we have x minus 29 over 19 over minus 3, and then we have y minus 8 over 19, and here we have 1, and then we have z minus 77 over 19, and here we have 3. So this is the required equation of the line of shortest distance. Now we can also write this equation as here we can now write 19x minus 29 divided by 19 times minus 3, then we have 19y minus 8 over 19 times 1, and then 19z minus 77 over 19 times 3. So here 19 appears in all these three terms, so cancelling it, we have 19x minus 29 over minus 3, 19y minus 8 over 1, and 19z minus 77 over 3. So this is the required equation of the line of shortest distance. So now here it is interesting to note that the equation of the line of shortest distance can also be written in terms of this coordinate, that is x2, y2, z2, right? We have just written the equation of PQ by using this coordinate, and this point Q also lies on the line of shortest distance, so we can also write the equation as x minus x2 over a, then y minus y2 over b, and z minus z2 over c. So here we have x minus x2 is 20 over 19, and here we have minus 3, and then y minus 11 over 19 over 1, then z minus 86 over 19, and here we have 3. So this is another form of the line of shortest distance. So we can also write it like this: 19x minus 20 over 19 times minus 3, then 19y minus 11 over 19 times 1, and 19z minus 86 over 19 times 3. So again, this factor 19, it appears in all the three terms. So cancelling it, we have here 19x minus 20 over minus 3, then 19y minus 11 over 1, and 19z minus 86 over 3. So this is another form of the equation of shortest distance. So viewers, this is how by making use of all these concepts we can easily find out the shortest distance between two non-coplanar lines L1 and L2, whose equations are given in the symmetric form, and the equation of the line of shortest distance, that is PQ, where PQ is perpendicular to both the lines L1 and L2. Hello viewers, in today's session we are going to discuss another important and conceptual problem from three-dimensional geometry. And here we are going to solve this problem where we have to find the distance of the point whose coordinates are 2 comma minus 2 comma 3 from this plane, whose equation is given by 2x minus 3y plus z minus 6 is equal to 0, and we have to find the distance of this point from this plane measured parallel to the line whose direction cosines are proportional to these numbers, that is 3 comma 4 comma minus 1, right? So here we have to find the distance of this given point from this plane, right? And the distance has to be measured parallel to the line whose direction cosines are proportional to 3 comma 4 comma minus 1. So here we are not going to find out the perpendicular distance of this point from this plane, right? So the perpendicular distance of this point from this plane is different from the distance of this point from this plane measured parallel or along to the line whose direction cosines are proportional to 3 4 minus 1, right? So let us first quickly see the definition of direction ratios, and then we'll draw a rough diagram of this problem to find out the distance of this point from this plane with this condition. So now here we are given a plane say pi, and the equation of the plane is 2x minus 3y plus z minus 6 is equal to 0, and we have to find the distance of this point, say point P, 2 minus 2 and 3, and we have to find the distance of this point P from this plane pi. Suppose this is the distance, and this point A is the point of intersection of this line PA with this plane pi, right? And later on we'll find out the coordinates of this point A, right? And this PA, that is this line PA, is given to be parallel to this line L. Say this is the line L whose direction cosines are proportional to these numbers 3 4 and minus 1. So we have to measure here this distance, that is PA, along this line L, whose direction cosines are proportional to 3, 4, and minus 1. So now, according to the definition of direction ratios of a line, we know that if the direction ratios of a line are A, B, C, and the direction cosines of the line are L, M, and N, then we know that A is equal to lambda L, B is equal to lambda M, and C is equal to lambda N, where lambda is not equal to 0 and lambda belongs to the set of real numbers. So now the direction cosines of this line L are proportional to these numbers 3, 4, and minus 1, right? So the direction ratios of any line which is parallel to this line L are given by A is equal to 3 lambda, B is equal to 4 lambda, and C is equal to minus lambda, right? So the direction ratios of any line which is parallel to this line L are given by the numbers 3 lambda, 4 lambda, and minus lambda, right? So the direction ratios of this line L may be taken as, say, lambda. If we take lambda is equal to 1, so we have 3, 4, and minus 1. So here it is important to note that since lambda is a non-zero real number, so for any line there are infinitely many sets of direction ratios. And when we take lambda is equal to 1, then we have A is equal to L, B is equal to M, and C is equal to N. So for any line, the set of direction cosines is also a set of direction ratios, right? So here the direction ratios of any line which is parallel to this line L are given by these three numbers, and for lambda is equal to 1, we have the direction ratios of this line L as 3, 4, and minus 1. So now if we assign different values of lambda to this set of numbers, then what we will get? We'll get a set of parallel lines, right? And here the distance of this point P from this plane pi is PA, and PA is parallel to this line L, right? So the direction ratios of this line PA may also be taken as 3, 4, and minus 1, because we know that parallel lines have proportional direction ratios, right? So now we can easily write the equation of PA in symmetric form. So equation of PA is now x minus x1 over A, y minus y1 over B, and z minus z1 over c. So a, b, c may be taken as 3, 4, and minus 1. So a, b, c denotes the direction ratios of PA, and x1, y1, z1 is our point 2, minus 2, and 3. So this form of equation is known as the symmetric form of the equation of a line. So we have x minus 2 over 3, then we have y plus 2 over 4, and z that is z minus 3 over minus 1. So this is the symmetric form of the equation of this line PA. So now our next aim is to get the coordinates of this point A, which is the point of intersection of this line PA with this plane pi. So let us introduce here another scalar or a real number, say R. So R is it belongs to the set of real numbers, and the coordinates of any general point lying on this line PA may be obtained like this: x minus 2 over 3 is equal to R, then y plus 2 over 4 is equal to R, and z minus 3 over minus 1 is equal to R. So we have three equations. So let us solve them for x, y, and z. So we have x, y, and z. So x is 3r plus 2. So here we have 3r plus 2. Y is 4r minus 2. And z is minus r plus 3. Right. So for some value of r, the this coordinate is represented by this point A, right? So the coordinates of this point A may be taken as 3r plus 2, 4r minus 2, and minus r plus 3 for some particular value of r. So the next our next aim is to get the value of this r. Now at this point A, it lies on the plane pi. So this coordinate must satisfy the equation of the plane. So substituting x, y, z as 3r plus 2, 4r minus 2, and minus r plus 3 in this equation, we have now 3r plus 2, then minus 3, 4r minus 2, and then we have minus r plus 3, and minus 6 is equal to 0. So this is a linear equation in R. So we have 6r plus 4 minus 12r plus 6, and minus r plus 3, and minus 6. So 6r, 12r, minus 12r, and minus r. So we have minus 6, and here we have minus 7. So minus 7r, 6 plus here 6 and 6 get cancelled, and 4 plus 3 is 7, and minus 7r is equal to minus 7. So r is minus 7 over minus 7, that is equal to 1. So for r is equal to 1, this coordinate represents this point A, which lies on the plane pi, and this point A serves as the point of intersection of this line PA with this plane pi. So now taking r is equal to 1 in this coordinate, we have x is equal to 3 times 1 plus 2, that is 5, and y is 4 times 1 plus minus 2, that is 4 minus 2 is 2, and z is minus 1 plus 3, that is 2. So we have the coordinates of A as 5, 2, and 2. So now we can easily find out the distance, that is PA, by using distance formula. So now if we take this point P as x1, y1, z1, and this point A as x2, y2, z2, then according to the distance formula, the distance PA is square root of x2 minus x1 square, and then we have here y2 minus y1 square, and z2 minus z1 square. So we have now here x2 is 5, so 5 minus 2 square, then we have 2 minus minus 2 square, and then we have 2 minus 3 square. So this is 5 minus 2 is 3, so 3 square. This is 2 plus 2, 4, 4 square, and here 2 minus 3 is minus 1 square. So this is 9, this is 16, and this is 1. So this is 25 plus 1, 26. So we have under root 26 units. So the distance of this point P from this plane pi is square root of 26 units. And remember, here this distance is measured along this line L, right? So the direction ratios of this line, that is PA, and this line L are equal or proportional. And remember, the this distance is not the perpendicular distance of this point P from this plane pi.